Robotik in der Industrie. Der Podcast mit Helmut Schmidt und Robert Weber. Hallo, liebe Zuhörerinnen und Zuhörer, willkommen zu einer neuen Folge des Podcastes Robotik in der Industrie. Mein Name ist Robert Weber und mir virtuell gegenüber sitzt
Helmut Schmidt, herzlich willkommen.
Helmut, grüß dich, schöne Grüße nach München. Wir haben heute eine etwas besondere Folge, denn ich habe im Vorfeld ein Interview mit dem Rich von Shadow Robots aufgezeichnet. Das hören wir dann gleich später. Das ist in Englisch, schon mal als Vorwarnung, also das Dictionary mal rauspacken, ja, falls man einige Begriffe nicht versteht. Doch wir starten mit einem aktuellen Teil. Helmut, was hast du mitgebracht?
Genau, ich habe ein Thema mitgebracht, unter anderem eine Eröffnung bei uns hier in München in der Pinakothek der Moderne unter dem Titel KI, Robotik und Design. Ist im Prinzip eine Entstehungsgeschichte der Robotik über Da Vinci, beginnend Golem und natürlich über den Professor Leibniz, Formel der Binarcodes, bis hin zu einem Ausblick, wo die Reise zukünftig hingeht und natürlich hinsichtlich Fake News. Also es gibt gute KI und schlechte KI, auch darauf wird eingegangen, wie man das negativ transportieren kann und die Kombination mit Design. Wir hatten ja den einen oder anderen Podcast schon zu Usability, aber auch zum Look und zum Feel wird immer wichtiger. Also jeder, der sich für Robotik interessiert, ist jetzt eine Ausstellung, die hier stehen bleibt und ist sicher interessant. Und nicht nur Design, auch die Robotik und KI sich anzusehen, hier bei uns in München.
Ja, sehr spannend. Ich hatte nämlich letztens ein Interview mit jemandem zu KI und der war verantwortlich für das Thema Machine Learning und Robotics in dem Unternehmen. Aber der hatte mit Robotics am Ende gar nichts zu tun, weil du ja auch die ganzen Programme, die Applikationen heute auch Robots nennst oder Bots nennst. Ja, also da verschwimmt alles sozusagen. Was sind Robotics? Ja, oder was ist Robotik? Robotik kann auch ein Bot sein, der dir einfach antwortet auf einer Website. Also sehr spannend, was da alles passiert und gerade das Thema Design finde ich super wichtig, das zu kombinieren. Das hat der Tom Kadere ja auch in unserem Podcast erzählt. Warum machen die Werkzeugmaschinenhersteller alle ihre Maschinen so hübsch mit Illuminierungen und LEDs und schön angesprüht und alles? Es ist einfach für die Mitarbeiter auch ein Gefühl, an einer tollen, gut aussehenden Maschine zu arbeiten, als mit einer, die einfach nur ein Stahlgerüst hat. Ja, also kann man vielleicht nicht direkt in Euros umrechnen, aber gibt ein positives Gefühl dem Ganzen.
Ja, auf jeden Fall und ähnlich wie ja in dem ganzen Thema Bauhaus, was ja auch dort aufgezeigt wird, zwar unter anderen Themen, eine komplette, wie sagt man so schön, Designwelle entwickelt hat, sieht man ja auch bei den neuen Robotern und bei den neuen Anwendungen, dass quadratisch praktisch gut auch dort nicht mehr steht, sondern es muss man ein bisschen nett anschauen und auch in den Werkshallen. Also ich glaube, von daher, das wird immer wichtiger und da wird auch ein großes Augenmerk drauf gelegt.
Das ist spannend, weil Stichwort Design, wir hatten ja mal so eine Designwelle, da hatten die E-Roboter, das hatten wir ja schon mal besprochen, alle Augen, weißt du das noch? Das war so ganz am Anfang, da hatten die alle Augen, da hat jeder ein Auge draufgeklebt und hat man gedacht, das ist einfacher für die Menschen, da mit denen zusammenzuarbeiten. Dieses Design hat sich zum Glück nicht durchgesetzt.
Nee, das hat sich nicht durchgesetzt. Gott sei Dank, denn am Ende ist der Roboter meines Erachtens immer noch eine Maschine, zumindest im industriellen Umfeld. Und wenn man auf die, sagen wir mal, Service-Robotik geht, ich glaube, da hast du ja auch eine neue Info dazu, da wird das ein bisschen kombiniert. Aber wie sich zeigt, ist das auch nicht immer unbedingt erfolgreich. Denn am Ende hat's was mit einer Identifikation zu tun. Und das ist eine sehr große Gratwanderung.
Genau, ich habe noch was zum Thema Design vielleicht, weil der Unimate feiert seinen 60. Geburtstag. Das war ja so der allererste Industrieroboter, der bei General Motors damals am Fließband gelaufen ist, um mit Druckgussmaschinen zu arbeiten. Und später hat er dann auch Schweißarbeiten am Auto gemacht und so. Der feiert Geburtstag und ich pack's doch in die Shownotes, gibt's eine schöne Zusammenfassung, eine schöne Geschichte dazu. Und das ist ja auch so eine Industrie-Ikone, auch vom Design her. Also da siehst du auch, schon damals war das Thema Design, spielte eine große Rolle.
Ja, also das ist eine tolle Geschichte. Es feiern ja dieses Jahr einige Jubiläum. Also das Wort Roboter feiert ja 100 Jahre
Genau.
Jubiläum. Der Unimate feiert Jubiläum. Aber auch der erste KUKA 6-Achs-Roboter feiert auch Jubiläum. Also das ist ein sehr interessantes Jahr auf jeden Fall.
Sehr gut. Ja, ich habe noch was im aktuellen Teil, nämlich Produktionsaus für Roboter Pepper. Was ist da los?
Ja, es ist eine gute Frage. Wir haben ja gerade über die Gesichter gesprochen. Ich glaube, das hat auch ein bisschen was damit zu tun. Das ist ein ganz liebes Teil. Insbesondere in Japan ist er ja sehr gut angenommen worden oder mit einer relativ hohen Stückzahl verkauft worden. Das ist einer der ersten Märkte. Final, was man allerdings hört, ist, dass er tatsächlich die soziale Interaktion nicht wirklich funktioniert, beziehungsweise dann tatsächlich angenommen wurde. Und jetzt wird er teilweise halt als Ausstellungsstück oder Gag verwendet. Was schade ist, denn in die Sozialrobotik muss investiert werden. Und das ist im Krankenhäuser-Servicebereich ein Riesenthema. Vielleicht war es auch zu teuer, ich weiß es nicht. Es arbeiten ja sehr, sehr viele an diesen Sozialrobotics. Ist schade, weil es sehr gehypt wurde, aber mich interessiert, wie es da wirklich weitergeht.
Fährt wahrscheinlich dann ins Museum, sozusagen.
Der wird wahrscheinlich, ist ein tolles Teil. Es wird wahrscheinlich als einer der ersten Roboter im Museum auch seinen Bestandteil finden. Aber ich denke, dort muss man weitermachen. Ist wie gesagt ein bisschen schade, aber die Service-Robotik wird super wichtig werden.
Ja, ich fand es immer so ein bisschen komisch, auf allen möglichen Events stand er auf einmal da um die Ecke und irgendwann war er inflationär irgendwo. Jeder, der ein digitales Event gemacht hat, hat sich da so ein Pepper hingestellt. Irgendwann hat es mich dann genervt auch, ja. Das war beim ersten Mal ganz nett und dann war es irgendwie, nee.
Ja, genau. Also am Ende muss er halt einen Nutzen bringen und nicht nur als Marketing-Gag herhalten. Und zudem ist er zum Ende wahrscheinlich verkommen. Das ist wirklich schade. Ich meine, wir haben ja hier in München Unternehmen Robotize, die eher diese Hotelroboter machen, ein bisschen mit einem anderen Fokus, aber auch im Servicebereich. Also der Markt ist gewaltig groß. Ich hoffe, der Pepper findet ein schönes Ruheplätzchen. Aber für alle anderen Startups, die an dem Thema arbeiten, lasst euch nicht entmutigen, bleibt dran. Ich bin überzeugt, ein wichtiges Thema für uns und für unsere Gesellschaft.
Sehr gut. Ein weiteres, ein großes Thema, das wir ja auch immer wieder haben, ist das Thema Bedienung. Und die Caroline Horn, die jetzt ihre Diplomarbeit bei Wandelbots geschrieben und hat einen Augmented Reality Interface Ansatz gewählt. Hier auch nochmal die herzliche Einladung, liebe Caroline. Wir laden dich gerne in unserem Podcast ein. Da würden wir gerne mehr zu erfahren. Ich bin ja immer bei dem Augmented Reality, alles, was du über Display lösen kannst, wirst du nicht in Augmented reinkriegen. Bin sehr gespannt, ob da was kommt und wie sich das durchsetzt, das ganze Thema. Weil wir haben ja schon Schwierigkeiten, erstmal die Cobots in den Markt zu kriegen und jetzt müssen wir Cobots mit Augmented Reality noch reinkriegen. Heieiei, ja.
Kann eine Challenge werden, wenn man allerdings Richtung Wartung, Ferndiagnose denkt, kann es natürlich schon eine coole Kombination sein. Also ich rede jetzt nicht rein von der Bedienung und Programmierung des Roboters, tatsächlich von Ferndiagnose. Wo sind die Mitarbeiter weltweit in ihren Werken unterwegs? Und die Leute stehen vor einem Maschine und du sitzt in München und der in Singapur oder wo auch immer. Mhm. Dort könntest du natürlich über Augmented Reality schon genau sagen, wo du was wie machen könntest. Also es ist eine coole Geschichte, aber auch das tut sich noch sehr, sehr schwer, wirklich den Durchbruch zu schaffen.
Naja, ich denke immer, der Ansatz muss doch eher sein, dass es noch einfacher ist, dass ich selber bedienen kann. Also dass dieses Wartungs-Instandhaltungsthema, dass es, also klar, das wird immer da sein, in Singapur, alles gut, aber du musst ja die Bedienoberfläche im Prinzip so einfach gestalten, dass du noch nicht mal Augmented Reality für das Ganze brauchst.
Ja, natürlich, aber meistens ist es ja, der Fehler liegt, wie heißt das schön, im Detail. Ja. Und dort ist man halt dann meistens mit der Usability am Ende. Aber am Ende sollte es selbst erklärend sein. Man soll es auslesen können, bedienen können und natürlich lösen können. Aber ich glaube, Fehlerbild können halt so mehrdimensional sein, ja, um dort halt zu unterstützen.
Zum Abschluss habe ich noch einen Tipp in eigener Sache. Ich habe einen Podcast aufnehmen dürfen für die Kollegen von Bosch Rexroth. Die haben ja auch ein AGV, nämlich das Active Shuttle. Und ich durfte als Moderator da eine Folge aufnehmen mit dem Marc Grötzinger zum Thema AGV und wie er AGVs mit Cobots und verheiratet und was sie sich darunter vorstellen und wie das in Zukunft gehen soll. Ich packe den Podcast in die Shownotes. Den sollten wir uns nochmal einladen, weil diese Kombination AGV und Cobot ist super spannend, Helmut, was die da machen. Also das ist echt extrem spannend, weil sie einen ganzen Supermarkt aufgelöst haben im Werk und im Prinzip das AGV mit dem Cobot interagiert und das alles ablöst. Also das ist super spannend, was die da vorhaben.
Ja, cool. Also das sollten wir uns auf jeden Fall anhören. Es gibt ja unterschiedliche Konzepte. Eines wie Magazino, wo komplette Regale rumfahren und beladen, oder eben die Kombination Cobot auf einem HEV. Also ich glaube, da ist das Rennen auch noch entschieden. Nee, lass uns das machen. Finde ich selber super spannend und die komplette E-Commerce und Logistik wird ja dort einer der Haupttreiber sein.
Absolut. Und genau, E-Commerce ist ein gutes Stichwort, weil um im Prinzip greifen zu können, brauchst du eine gute Hand. Und der Rich aus UK, schöne Grüße nochmal ins Vereinigte Königreich, heute zum Freiheitstag der Briten, mal gespannt, wie die Freiheit so ausgeht, hat eine Robotikhand entwickelt und sie behaupten von sich, sie haben die beste Robotikhand der Welt. Und wir beide haben das Video gesehen auf LinkedIn und haben uns gedacht, hey, den müssen wir unbedingt interviewen, weil du kanntest die vorher auch noch nicht, oder?
Nee, ich kann's ja vorher auch noch nicht. Es wird ja viel an dem Thema Greifen
Ja.
gearbeitet, bis ich den ersten Spot auf LinkedIn gesehen habe. Ist eine coole Geschichte und ich freue mich auf das Gespräch und das Interview mit ihm.
Und da hören wir jetzt rein. Wir wünschen euch erstmal einen schönen Sommer, nämlich das ist erstmal die letzte Folge vor der Sommerpause. Im August machen Helmut und ich nämlich auch mal ein bisschen Entspannung. Der Helmut hat einen neuen Job, der muss sich dann erstmal voll darauf konzentrieren. Der darf nicht in Urlaub, aber ich darf ein bisschen in den Urlaub fahren. Und wir hören uns dann wieder im September mit neuen Folgen.
Genau, wir freuen uns auf euch. Schöne Sommerferien und bis zum Herbst.
Hello, Rich. Greetings to the United Kingdom.
Hi, thank you very much. It's great to be here today.
Rich, we had a lot of email and writing to find the agenda and to find an appointment. I'm very happy that you have now time for us. Please introduce yourself shortly. Tell us something about what's your background and who is Shadow Robots.
Sure, thank you. So I'm the managing director of the Shadow Robot company. Managing director is kind of similar to CEO in American companies, but it's a little bit different. The UK has its own corporate governance models. I'm also one of the directors of Shadow Robot España, which is our Brexit hedge that we set up in 2017 that turned out to be a really good idea. And I'm one of the directors of the European Association EU Robotics and ADRA, which are the associations that look at respectively robotics and AI, robotics and data, and interface with the European Commission. My background is that I'm a mathematician who really liked playing with computers, and I wanted to write AI software for robots. So I ended up building the robots, and then I ended up running the robot company.
Why is your company called Shadow Robot?
So there's it's a great word to have because people actually think that we're talking about what we do, which is we do a lot of stuff in teleoperation, and in teleoperation, the robot shadows what you do. But that's not actually the origin of it. Our founder, Richard Greenhill, set Shadow up in the 1980s, which is, at the time it was a group of people building robots for fun. He had this fantastic vision that robots could do all sorts of cool stuff in the home, and he just started building them. And he got a bunch of like-minded people together, and we used to meet once a week and build them. And he started out calling it the Lucifer Project because Lucifer is the light bringer. Mm-hmm. And then, well, he was going to go on an early version of the internet called Prestel, an online bulletin board system the UK had. And the moderator of the online chat said just before they started, he said, if we talk about this as Lucifer, he said, we're going to spend most of our time talking to people about Christian theology. Which is, oh yeah, that's a good point. Is there any other phrase you could use? And he well, actually, light, shadow, me and my shadow. Yeah, actually, if I'm going to build a useful robot, then it could be a shadow. So we changed to Shadow, and we've been there ever since.
When I heard the first time Shadow, I thought you are the shadow of the robot because are you a robotics or an AI company?
We're definitely a robot company. We're an AI consumer, and a lot of our customers are in AI. But we're focused on what we see as the interesting bit, which is building real objects, making things work, and sending them out in the real world, so that people doing AI have something to ground their research in, as it were. When we started, we thought that it would be relatively easy to get robots to do things because there'd been lots of research on how to get robots to work. And it turned out that there had, but it had all been done on very, very simple robots. So when we started building things with the complexity of the human hand, which is what we're known for, we found that everybody in the R&D community went, oh, wow, okay, we're going to have to work out what to do now. And so we kind of kicked off a whole area of research around how do you control robots that are like human hands to get them to do tasks.
You mentioned the AI companies. You work with OpenAI and many others. What is the benefit? What is special about your application? Why they choose Shadow to work with?
I think there's a couple of things. Firstly, we're very good at what we do.
Sure.
It's simple, put very simply. I know that sounds kind of big-headed, but we spent a lot of time doing the transition from being a robot company that does lots and lots of things, and we're good at all of them, to a robot company that does one thing ridiculously well. And we're kind of known globally for being, you want the best robot hands in the world? You go and talk to Shadow. And that means we spend a lot of time doing support, making our systems open, making them versatile and usable by people doing hard R&D problems.
Mm-hmm.
But I think the other reason why, that's why you'd work with us, but why would you want to use a robot hand? Well, remember that the human brain spends a huge amount of its processing capability dealing with the hand. The muscle control, the sensory operations, how it generates actions, and the hands are how we interface with the world. So in some sense, if you want to show that your AI is really doing stuff, then giving it a hand, giving it a pair of hands and getting it to do things is the best way to show humans what it can do. Mm-hmm. And what we found was that the AI researchers were saying, well, if we can control a robot hand that's like a human hand to do real things, then we've reached some kind of benchmark of comparable with the human brain in one area. We can do that bit. We may not be able to do these other bits, but actually interacting with the world is really hard. It's a thing called Moravec's paradox. Like, it turns out that actually picking things up and holding them is really difficult.
Mm-hmm. Tell us something about your hand and what makes it so special. What makes it different from the Festo hand? I'm sure you know the Festo hand they developed together with Nascent. What is different and what is maybe the same?
Sure. So we took almost a straightforward approach in what we did, and we said, let's build something that is as close as possible to the human hand. Mm-hmm. And we deliberately went through a process of cutting no corners. We said, how can we make it really, really, really close? I remember there was around about a year when every time we had an engineering meeting, two of my colleagues argued over whether or not they could use an extra millimeter of thickness in the palm. Mm-hmm. And if they used that millimeter of thickness, it would be easier to make the electronics, but it would then not be the same dimensions as a human hand. And eventually the dimensions won, and we packed the electronics in. So we have pretty much the same movements as a human hand. There are, depending on which anatomist you talk to, something on the order of 25 movements in your hand. The base of the thumb is complicated, and a lot of joints dislocate and relocate in kind of interesting ways, and the palm has this really weird property of the way it bends around things because of the bones that run up the back of it. So we simplified a little bit, but we put 4 movements in each finger, 5 movements in the thumb, 2 in the wrist, and an extra movement on the little finger to emulate that curling of the palm. And these are all controlled by motors these days in the forearm, very precise Maxon motors that give us really good motion control. So from Switzerland, absolutely. They still make the best motors in the world, and yeah, they know it, and we know it too. And their prices reflect their quality, shall we say.
Okay. So you have these motors, and which role does the software, the AI, plays for you?
So what we need software to do is to say, what should we do with the hand? How should it move? If we're going to pick up an object, what posture should the hand adopt? When we move the object, the hand into contact the object, how do we interpret the data that comes back from the sensors and says, we have a contact there. We can see the forces in the tendons are increasing. And then if we're holding an object, how do we understand that the object is being held well and isn't going to fall out of the hand?
So we're talking about a lot of data. What you are doing with this data?
So we have, I think it's 100 sensors in a typical hand, and they're streaming data at around 1 kilohertz into the control computers. And that's a lot of information that you can extract.
Control computer is next to the robot, or is it the PLC of the robot, or is it a special one?
It's typically next to the robot. So actually, if you look at one of our hands, you'll see there's an Ethernet connector at the bottom of it, and we use EtherCAT to talk to typically a laptop or a NUC or something. Doesn't need to be a very high-spec computer to run the hand itself, because we tend to move the intelligence off somewhere else. We're using ROS, so we can put together a cluster of machines that talk to the hand very, very easily. That's nice and simple. And then you do your vision somewhere else, looking at the world and interpreting it and recognizing objects, and then synthesize a grasp, and then drive the robot hand to the right place and the arm it's sitting on to interact with that object to pick it up.
Mm-hmm. Is it a reinforcement learning, or what are you doing with this hand?
So we do very little AI. It's kind of interesting to note, but people who like OpenAI, who have been using the hands and doing impressive things with it, are typically using a reinforcement learning approach. They build models, simulations, they explore in simulations, they do policy learning, and they then apply that to the real robot hand. And there have been a lot of successes in using that to generate interesting ways to operate the hand. Equally, we often work from the what you might call the engineering approach, which is to say, well, there are only so many different ways you can shape the hand to pick up an object. There's a taxonomy of these. There's about 20 or 30 of them. Okay, which one of these does a human use to pick up an object like that? That one. Mm-hmm. All right, fine. How do we now control that one to do a grasping? So we might just write an algorithm for how do we use that grasp on that object, and how do we maintain stability, rather than have to invoke the full kind of mechanisms and power of the AI tools and technology.
Mm-hmm. How difficult is it from your point of view to get AI and robots together?
It's interesting that it's how can I put this? There's often a semantic problem. If you talk to politicians, when they say AI, they mean all of robots. This stuff that's like machine learning and robots and big data and the things that people like OpenAI are doing and what Google search does, and they kind of think of all of that under the banner AI. And it's this kind of, in political science, it's effectively a convenient term for the wave of disruptive technologies that are happening at the moment, where computers are becoming embedded in everything and data is coming from everywhere. When we deal with people who are doing the kind of actual hard AI problems, machine learning, data science, statistical analyses things, we find that actually mostly sorry, it's my cat. He always likes to join my calls. We find that they're often on a similar level to us, in the sense that they understand where data comes from and goes, and how to collect it and how to do it. The biggest challenge we have is that if you've been used to doing things in software, hardware is unforgiving. Really, really unforgiving. Software, it's unusual for you to cause the software to break by running it in a way that means you have to send the whole computer back for repair. Hardware, it's easy to break it by running it in a way that means you have to send it back for repair. So we have to deal with that kind of difference in how you approach the thing and how you treat the thing. But actually, mostly we find it pretty easy to engage with people doing AI-type research and saying, this is how you can connect this to there, and here's some nice open APIs, and here's where the data comes from and goes, and do you need any more data? Because we can always add some more sensors.
On your website, you write, you remove bias. How is it possible, or why do you remove bias?
So I think the element here is that if you're actually doing something with a real physical machine in the real world, your assumptions about your simulations in particular go away. So we often see that people will build a simulated system, operate the simulated system, and you'll look at that and you'll say, well, that's really interesting, but you have everything happening simultaneously because you have a fixed time clock. Whereas in reality, as it were, outside the simulation, things happen in a different way. They're not synchronized like that. So the world has greater richness, greater continuity, and we find that means that if your algorithms are fundamentally perhaps oversimplified, or you have assumptions in there that aren't as true as you'd like, then actually running real robots means that suddenly that becomes very, very clear. All those second order terms in the approximation that you just said, yeah, we'll use a linear approximation for that, all of those suddenly come back and bite you.
Everybody's talking about AI, and you mentioned machine learning and what is strong AI and weak AI and stuff like that. Everybody wants to do software, and now you are a hardware company. Are you afraid of being a hardware company?
So I think it's Cisco who used to say that software eats everything eventually.
Yeah.
And I'm like, yes, you're right. But equally, Cisco's business is selling boxes that run that software that are highly optimized to run that software. So they've changed one part of the system, but they're still selling hardware. Mm-hmm. And we think that, frankly, we like building things. We like making stuff. We're in this because we like building physical objects that operate in the world. If we spend all day doing software, then yeah, there's lots of interesting things there, but it's not fundamentally as satisfying as seeing a robot arm reach across the room and pick something up and do something with it. And if you want to get your technology out of the lab and into the real world, then physical embodiments are a really good way to do that, because physical embodiments by default are out there in the real world already.
Mm-hmm. I want to come back to the AI topic and the reinforcement learning. Do you think that this is a future for robotics, the reinforcement learning?
I think it's how can one put this? It's a really useful tool for the toolbox. Mm-hmm. I think that there is a strong argument that people working with reinforcement learning and its relatives have got systems to do far more complex tasks than we have seen before. AlphaGo, for example, absolutely stupendous. But that wasn't just reinforcement learning. There's a bunch of other techniques built into that system. But I think what it's given us is a really good way to get machines to tackle things that were hard to write down the equations for. And I tend to see these things as, you might call them universal function approximators. If you're doing engineering and you're sort of writing down on the whiteboard what's going on with the system, and we can model that bit is really complicated. Okay, that bit that's really complicated, can we get a reinforcement learning system to learn to do that? Because if we can't model it, then that's a better approach.
What are the most important components in your hand? Is this a motor? Is it a sensor? What is the most important?
Motors are very important. It's really interesting. Every so often, one of the motor companies comes to us and says, we've got a new range of motors. They'll be fantastic for what you do. And we kind of look at the spec and we go, no, not quite there. Because actuation is a real challenge. But the thing that differentiates a robot from other mechanisms, as it were, other things with motors in, is that you have the actuator, the motor, and the sensor, the joint sensor, the touch sensor, the force sensor, and you look at the control in the loop at that level, but then you also look back one step and you say, now, what behavior do we want it to have, and how can the behavior change? So it's the two levels of having both the sensor actuator loop closed, but then changing the behavior based on observation of the world or commands. So for me, it's both things. It's the physicality of taking data and using it to drive motors, but then it's also the approach of saying we think of that as a whole system and give you a way to control it as a system.
Mm-hmm. On which industries do you focus? I think in process chemistry industry, space industry. What kind of industries do you focus?
So we've done business in lots of areas because we're very good for R&D people. We spend a lot of time dealing with people at the cutting edge in organizations, people in innovation labs, people trying to find out what can be done in the future and build first prototypes just to see what happens. We've done a bit of work in space. We count NASA and ESA as customers. But that's not a regular paying business, as it were. Mm-hmm. These days, we're kind of focused on three key areas that we see what we can do. So we have the Roboterhand that people in R&D are buying, but then we teleoperate this. We have a human in one place control the robot hand in another.
Yeah, I saw this on the video. Yep.
And that suddenly opens up lots of possibilities. It's really fantastic. You must come and try the system when the travel restrictions are lifted, mm-hmm. because it's a really impressive experience. And we're talking to a lot of people who do remote engineering. So send someone somewhere to do an engineering task in a hurry because something is broken. Okay, how can we use this system to do that? We're talking to a lot of people in the nuclear community because they've been using remote technologies for years and years and years, and this represents a significant improvement in what they can do in remote technologies. And we're also talking to people in pharmaceuticals. It turns out that pharmaceutical manufacturing processes are all about keeping the human away from the material, but still allowing human interaction. So you see isolators with glove ports, you see people in sterile clothing and so on. And if you can use a robot with hands instead, then you can improve the process safety, as it were. You reduce the risk of contamination, increase uptime, make work easier for the people doing it. And that's very much what we think we do well, is to make awesome robots so that we can make people's working lives better.
I read on your website that Siemens is also a customer from a German perspective. What they do with your hand? Research?
So I'm just mentally checking the NDA around that. So they're always NDAs, wallpaper your office with them. We have 2 or 3 customers like Siemens who are exploring what they can do in future production. So at the moment, you run a production line one way, you're starting to bring in these Industry 4.0 concepts, and that's fantastic, and that's increasing flexibility and giving you an overview of how the production system operates and being able to change it more dynamically. But if you walk along a production line, you'll see people, and those people are doing tasks that the human hands are necessary for still. So what companies are often exploring with our hardware is these tasks that we still have humans doing in production processes, that are often bottlenecks as well. Can we get robots to do those so we can free up the humans to do other skilled tasks that they can do?
And at this point, AI and the robot comes together once again. Because when I have the robot, the camera, and the hand, I need the AI algorithm, what he's doing.
Exactly. And you teach the robot how to do things. And once you've got that loop closed, you suddenly find that you have a much more capable system. But also, when you take that Industry 4.0 view and say, this production line is going to change what it does from time to time, AI gives you the opportunity to say, aha, new task, let us quickly train the system, and now it can do that new task.
Rich, thank you very much for your information about the Shadow Robot, and greetings to the United Kingdom. Stay safe and take care of you.
Thank you, Robert. An absolute pleasure today. Stay safe yourself. Thank you.